Hello again, this is Keith Parsons with Heavy Wireless Podcast. We're part of the Packet Pushers Podcast Network, and we're glad you're with us and listening today. Today I have Howard Buzick of Ameriband, and we're going to talk about kind of the history and where we started and where we are now on how wireless connections happen in a guest network environment. Howard, how are you today?
Doing great. How are you?
Well, let's jump right into, start with a history of these Wi-Fi connections and how you were involved.
Well, so I kind of got started I got introduced to Boingo Wireless and joined Boingo Wireless when I was working with Sprint. So Sprint back in the day tried using WiMAX as their 4G technology, and that didn't work out so well. So they saw Wi-Fi as a great way to add additional capacity to their network. And so they initially got involved with Boingo using a technology called Whisper, which is a way to use username and password and scripts beneath the scenes in a website. And they quickly transitioned to Passpoint, which was originally called Hotspot 2.0. And now that name has been deprecated. It is all called Passpoint from now onward.
Okay. And there's also a whole series when we used, back in the WEP days, if you didn't want WEP, you just had open. And for a long time, we just had open networks, and then people wanted to have the evil, dreaded captive portals. And we all know how much people love captive portals.
They're still around today. People still love them to a degree.
They love them because some lawyers are advising their companies, well, you have to have this because legally in some countries, in some places it is. But if you check with small companies like Apple or Disney who don't use captive portals, they have a few lawyers on both of those teams, and they figured out how to not have to have captive portals. But let's talk about Hotspot 2.0, or as it's been rebranded, Passpoint. How does Passpoint work?
Well, Passpoint is designed to be a secure and automatic solution to get folks on the network. So there's really three main technologies on the authentication side that are used. One called EAP, aka/EAP-SIM. And then there's also EAP-TLS, which is certificate-based, and EAP-TTLS, which is encrypted username and password. All these have the advantage of requiring a full authentication in order to get people connected. So it eliminates man-in-the-middle attacks and has the additional benefit, of course, of the devices connecting automatically as you walk in range of those networks. So it's a secure, automatic connecting technology.
Now, when you say automatic, if I have a Passpoint profile on my phone and I walk into an area, it hears a beacon and then it automatically just joins if it sees the correct SSID?
That's correct. So that technology to discover is called ANQP. And the network sends out a beacon that the profile recognizes and does an automatic connection. So the phone could be in your pocket and you'll connect. And of course it works for tablets and laptops as well.
The bugaboo in that is, how do I get that profile? Unlike a captive portal where I see a public, accessible, open broadcast SSID, then as a user, I click on it and then it sends me someplace. How do I get that Passpoint profile so I don't have to make that decision myself?
Well, there's three common ways to get profiles onto your device. The easiest way is for SIM-enabled devices. Often when you provision the SIM card or eSIM, it'll download that Passpoint profile as part of the carrier settings bundle. That applies to phones, tablets, SIM-enabled laptops as well. And so you just get that profile automatically. That's the easiest and best. You can go to certain locations and download profiles, which, depending on the OS you're using, might have additional steps of downloading and installing and accepting various dialogues to get it in. And then the third way is to embed a Passpoint profile inside of an app, which has lots of advantages. Although if you have lots of profiles that you want to have for various purposes, you can end up with lots of extra apps on your phone you might not like, but it's a pretty smooth way to install those profiles as well.
How does the process know the priority, the order of which profile I'm going to, if I have 5 different profiles, they're all Passpoint qualified, which one gets used first?
Well, that can vary by operating system, but there's one feature in Passpoint that does help a little bit. And that is that there's an idea of a home network. So you can have a Passpoint profile that's designed to log on to your campus network, and it'll always choose that one first ahead of additional profiles that might be available. But I will still admit that you can choose what might seem quite randomly from the remaining profiles if you have a number of them.
Well, in this space of captive portals, public access Wi-Fi, one of the biggies out there has been EduRoam for the last, 15, 20 years. If you're part of higher ed, your credentials at your university or even your community college would allow you to join any EduRoam SSID anywhere in the world. The EduRoam SSID is consistent, always lowercase EduRoam, and your credentials are then authenticated back to wherever your institution is. And that's been around for a long, long time. But it only is good for people who are part of the edu community. Another group is trying to come up with open roaming, and open roaming is like EduRoam, but you don't have to be part of a edu, but you do have to be part of the open roaming community. What is open roaming, and how is that different or the same compared to Passpoint?
Well, so Passpoint is the underlying technology that allows all the connectivity to happen. It does the authentication piece. It has that ANQP discovery piece. So you don't have to have a specific SSID to get people connected. So Passpoint is the architecture of making it work. Open roaming is literally a federation that is actually trying to be very much like EduRoam, right? You have various identity providers and various people that provide access to their networks. And so it just takes away the requirement that it be a single SSID like EduRoam. The SSID is flexible because of the Passpoint technology for beacons and discovery. So open roaming is definitely, that federation is designed to be like EduRoam using the Passpoint technology.
So EduRoam, each university hosts their own authentication server, the whole authentication process. They also publish and transmit the SSID EduRoam on their network, and then anyone who is qualified can use their network, and then they pass the authentication back through EduRoam. But with open roaming, you have to be part of that federation. How do you get an open roaming credential?
Well, sometimes you can get it automatically by the fact you have a certain type of device. Lots of Samsung devices include a Passpoint / open roaming profile. And there are other sources where you can get them. So open roaming profiles are distributed by retail chains in Belgium, for example. And the question is, how inside the federation are you provided access to various networks around the world using that community or that federation? So it's still typically installation of an app in most cases. The mobile operators / carriers out there are still using kind of a vanilla Passpoint profiles, typically EPKA. So they're not literally part of the standard, although, that's part of the intent is to get all players to provide these open roaming profiles.
Well, let's move past open roaming and talk about what Ameriband does. And you use SIM credentials, and it's Passpoint is the underlying technology. And how does it work if someone wants to use Ameriband in this whole Passpoint environment? What's your uniqueness there?
Well, so at American Bandwidth, we focus on one problem and one problem only, and that is to resolve indoor coverage using those existing carrier Passpoint profiles, the EPKA profiles. And so I guess our secret sauce is that we have the interconnect with major U.S. carriers at this point, although we're trying to evangelize it to carriers in other countries as well. And that the technical interconnect with the carrier is a very key component. The other component is the ability to configure an enterprise-grade Wi-Fi network to support that standard, get the interconnect through us, also optimize their settings for real-time communications like Wi-Fi calling so that it works from end to end. So, at American Bandwidth, we're focusing on configuring those enterprise networks and then connecting them through to those carrier networks to, once again, provide good indoor coverage. We're solving indoor coverage problems using Wi-Fi.
Well, hopefully our listeners are people who love to fix indoor Wi-Fi problems, and they have the skills and abilities to make their indoor Wi-Fi work great. What they probably don't have is the ability and skills and access to the technology to solve cellular indoor problems. And have you found, I mean, we've all found over the last 20 years, cellular doesn't go everywhere. So when you say indoor wireless coverage, are you talking about cellular or the Wi-Fi or some combination?
So we're using the SIM credentials from the carrier to authenticate onto the Wi-Fi network. And so they're using 5 gigahertz, 6 gigahertz spectrum to provide cellular services, essentially, because it's using the carrier credentials to put them on that network. And what's great about it is it all pipes through the guest VLAN, which then gives the person that's administering that network complete control of what's happening on that network. So typically it's internet access only, but there may be other policies. If it's, say, a K through 12 school district, they have SIPA compliance, they need to filter certain types of content. And that all applies to them in a way that they don't get to actually do if they deploy the cellular solution inside their building. This
kind of sounds like a DAS replacement.
That's kind of our intent. I mean, DAS, as we all know, is relatively expensive. It's $3 a square foot or more. And this is, we believe that a Wi-Fi network properly deployed, it's a distributed antenna system. It's a DAS, that it just needs to be configured properly to serve this purpose. And there's really not any gaps in capability which Wi-Fi calling is properly optimized for. And actually, one of the tiniest of tiny gaps that was there was it remains until, I guess, September of this year, when Apple starts supporting RCS on their phones. Right now, if you try to use iMessage and talk to an Android device, it kicks you out to use SMS. And if the cellular signal is highly attenuated indoors, that can result in problems, but that will go away. And we'll use an Apple device talking to an Android device will start using the data channel for RCS.
When you said Wi-Fi is a distributed antenna system, kind of threw up a little bit in my mouth. It just made me, ugh. But then I had to think about it a little more, and it is. We use Wi-Fi and the whole 802.11 technology stack to deliver a wireless signal with various antennas closer. So it is distributed antenna. It's definitely not cellular service. What do you have to do to a Wi-Fi network infrastructure to give it the efficiency it needs to support Wi-Fi calling as good as a cellular would be outdoors?
Well, I mean, most people that know how to configure an enterprise-grade Wi-Fi network have pretty good control of the main features. So it's fast roaming or 802.11k and R, for example. And then there's one little quirk is that for Wi-Fi calling to happen, the handset actually sets up an IPsec tunnel to the carrier's Wi-Fi calling or IMS servers. And sometimes the firewall rules can get in the way of those tunnels being built. So that's some of the things that are on our checklist when we're looking at a network, just to make sure that those services aren't being blocked. But if they're not, the 5 gigahertz and 6 gigahertz spectrum have tons of extra capacity, way more than any cellular deployment could do via a traditional DAS.
So you have customers, and they're currently running this. What kind of additional load might they see across their infrastructure if they start carrying the Wi-Fi calling that would have went over a cell carrier, but it's now going over the Wi-Fi calling?
Well, keep in mind that Wi-Fi calling is a relatively small percentage of people's usage on their cell phones in general. So, but it's kilobits per second. It's not much throughput. But even when you include the normal usage of email and other applications on your phone, per tier 1 carrier we enable, it's like a 5% increase in network usage. So it's, generally speaking, what we've seen is, because we're trying to solve for indoor coverage, that people are already crowding onto the guest network in other ways because they're having trouble with their cellular service. And we're just getting people connected automatically. So more devices are connecting securely and automatically, but it drives a little more traffic, but not a lot. Once again, 5% per tier 1 carrier.
How would a customer know, what would the metrics be that say, I think we have a problem with cellular inside our building, and we know that our Wi-Fi works? How would they make that decision? I know my wife and my children and grandchildren, always complain about the Wi-Fi, and I'm like, the Wi-Fi is fine. It's your cell carrier, and they don't know the difference. How would you help a customer make that decision to say, oh, we are having a cellular issue rather than a Wi-Fi issue?
Well, I mean, typically the people we end up working with are the same folks that can configure a Wi-Fi network, so they're IT professionals, and they know enough to differentiate between Wi-Fi and cellular, and they can use any of the number of various speed test apps that also look at your signal quality and compare them. And so, yeah, I guess part of the challenge as 5G's got rolled out is that most 5G services are using mid-band spectrum and higher. So it's really not penetrating walls very well. And that's easy to detect just looking at the number of bars appearing on your phone as you walk to the middle of a larger building, for example. So it's not that hard to detect. And once again, usually these Wi-Fi networks have tons of extra capacity and have excellent coverage inside those buildings.
Well, I'm sure this is different for every vendor maker of a handset, but what is the algorithm? How does it, let's just pick an iPhone because I have one in my pocket. How does the iPhone determine I should make this next call over the cellular network or over my Wi-Fi calling? Where's the metric? How it makes that decision?
Generally speaking, it's pretty simple, a heuristic. If you're connected to Wi-Fi and the phone can make an IPsec tunnel to the carrier's Wi-Fi calling server, you're going to make a Wi-Fi. It's Wi-Fi calling for you. So if you can and you're connected to Wi-Fi, you will. Is typically how it works. Well,
that's sure good news for the cell carriers, because then if I have a bad situation, I'm not blaming AT&T. It's like, oh, stupid Wi-Fi.
Well, once again, people often don't know who to blame. But that's it's a device that has lots of radios in it, so it's really hard to lay the blame. And one caveat I'd bring up is that if you're making a phone call to call 911, it's actually totally different. So phones have a special behavior when you do it down 911. It actually picks the 2G carrier with the best signal in that location and tries making a phone call to them, like circuit switched. And then that carrier is responsible for triangulating the location. So you'd almost never use a Wi-Fi calling when you're doing a 911 call.
Is there enough 2G coverage everywhere? And I'm assuming is using lower band frequencies, which penetrate a little better.
Correct. That's why it's all been designed that way. So the E911 program is working directly with the handset manufacturers for this model. And yeah, unless you're deep in a mine or in a sub basement in some types of buildings, you're going to get a good 2G signal. So
the only time the Wi-Fi calling would make a 911 call is if you had like
0 bars. Yeah. So I mean, if you see on your phone, you have like the SOS logo appears when you're in a bad location. That means your current carrier doesn't have coverage there, but there's an alternative carrier available to you.
Oh, is that what that means? Always good to learn new things. Yeah, that's why you sign up and listen to podcasts. You can learn things like that. So let's take an example of one of your customers. That doesn't matter, just pick one, some retail customer who wanted to solve their indoor Wi-Fi problem. What's an experience of one of their customers as they walk into, let's just say they're a retail store.
I mean, it's really as simple as walking into the store, right? So you're outside, you're on your cellular network, you walk to the front door, and once you're in close enough range of the Wi-Fi network that you can discover the Wi-Fi network and the authentication, the AKA authentication can successfully get from end to end, you're going to connect. So if you're in an attenuated situation where you have bad coverage, it won't authenticate. But once you get in a good enough range to start passing a decent amount of data, you will connect securely and automatically. So if your phone's in your pocket and you walk into the store, you're going to start getting your data services and phone calls over Wi-Fi without really being aware of it at all.
When you say not being aware of it, that means there's no end user interaction. Let's back it down all the way to the nitty gritty. So you walk in and your phone hears an SSID. It could be the store's SSID. Mm-hmm. And what makes my phone choose to associate, even though I don't? It's the first time I've ever been in the store.
So once again, the way we do it is we're partnered with the carriers. So the carriers have what's called a PLMN ID or an MCC MNC. So that's mobile country code, mobile network code. Every carrier's got multiple of them. The profile on the phone is listening for their specific PLMN ID, which is it's the same network identifier that comes off of a cell tower or a small cell or a DAS network. It just happens to be coming off of the Wi-Fi network. So it's like we're turning every access point into a mini cell tower from that phone's perspective. So when it sees that PLMN ID being broadcast that matches its Passpoint profile, it immediately kicks off the EPK authentication for that SSID, regardless of what that SSID it is. It really is irrelevant what the SSID is.
And then it's associated. It uses the eSIM or SIM credentials. Just pick T-Mobile, and the T-Mobile authentication server says, yes, you're good, and then it finishes the association.
Correct. So we do check with the carrier AAA to verify they're a current user in good standing. And then the messages get sent as code authentication accept. And then based upon the Passpoint standard, the Wi-Fi network sets up an AES 256-bit encrypted connection. And then we work with that network to configure it to use the guest VLAN and then give recommendations on how they can optimize that network.
So that one of the services you provide is that SSID they choose. Could it just be their normal retail SSID?
Typically, no. So it has to be a secure SSID meant for purpose. There's some edge cases where we're working with folks to maybe have an existing edge-roam SSID serve both purposes. Haven't quite figured that out yet. It's just the way the different equipment manages the radius stack and all that fun stuff. So typically it's a unique SSID. And keep in mind that
but it doesn't have to be a specific name. It doesn't have to say any specific name. It could be anything.
We have partners we work with a .p or just a tilde in there. You don't want people to try to connect to it. It should be an automatic connection, so it should be non-obvious in most cases. And one feature of the Passpoint profile is it has kind of like a friendly name or a subtitle. So if you're connecting with a T-Mobile profile, for example, it'll say T-Mobile Passpoint as like as the name underneath whatever the SSID is. So there's some indication there that you're getting connected by your carrier.
But the end user doesn't have to do anything. He just walks in, they have a T-Mobile SIM, yep. They connect, and they're transmitting data.
Correct. The 5G logo gets replaced by the Wi-Fi rainbow, and they're up and running.
Sounds amazingly simple. Are there others
who are doing this?
Simple. Yes. Are there others who are doing the same kind of thing you're doing?
There are other ways to do it. I mean, I used to work for Boingo Wireless, and Boingo is doing this quite heavily at all of their managed venues. So at places like LAX and other locations where they manage the Wi-Fi network, they allow lots of folks to connect to it using Passpoint. But what we're doing is, I guess, more specific. We're trying to get people interconnected. So I guess another competitor in this space would be Google Orion, but different business model. I think they're focused on monetizing networks, where we're focused on solving indoor coverage. So it's a different perspective on how to solve that issue.
And when you say you're focused on fixing indoor coverage, that's indoor cellular coverage.
Correct. When your cellular coverage is bad indoors, we're going to work with the big carriers to get them to connect automatically in your building.
Well, can you give us your elevator speech? What makes Ameriband unique? And if people want to, and when you're done, tell us how to get in contact with you.
Sure. So, I mean, we've kind of covered most of these details, but our secret sauce is that we basically help you configure your network. We have kind of a white glove service. Takes about an hour over the course of a Zoom call or a Teams call to walk you through your configuration to not only enable Passpoint, but optimize your network for cellular services across all your SSIDs. And that really solves the problem. So we are already interconnected with the larger carriers. And so we're just connecting the dots. And our service does include detailed usage reporting. And so we report back both to the carrier as well as to the venues that get involved. And if they have lots of buildings, we could break it down on a building by building and carrier by carrier basis for them. And that's something that comes automatically through enabling our service. We have a full usage reporting portal for them. And we even send people some alerts if there's anomalies in the data, if the usage levels look different than they typically do, for example. So lots of bits and pieces there, but we're trying to be, as you mentioned before, a DAS replacement.
Well, fantastic. Thank you, Howard. And just on a side note, I've worked with Howard, and Fernay and I worked with him on both setting it up in Fernay's man cave, and I had it in my lab, and we've done it at a local Utah conference. And have to say, the process is amazingly simple. Depending on the vendor, some of them, we did some sub 5 minutes and it was up and running. My in-laws came into the building and I said, "Are you connected?" And they looked at their phones and they were on their, they didn't know my SSID. They didn't even ask my guest network, and they were just running. It's just like magic. If you have a SIM in your phone and you need guest access, it just happens automatically. So fantastic. Thank you, Howard, for your time. And I'd like to thank our listeners. You've been listening to another episode of Heavy Wireless. We're glad you joined us and look forward to talking to you in the future.